Okay, guys. Hello. I am in my backyard because it's a beautiful day. What I wanted to do real quick was just walk you through a couple of things for Module 5B, which is a system of equations project. There are some videos, if you look on the assignments, there are some videos from like Khan Academy and stuff that will walk you through a couple of these different types of things. But I wanted to just go ahead and put together a quick video so maybe you can get all the stuff in one place. So I'm only talking about part 2 of the project. Part 1 of the project, there are some notes that you can find that I'll put on Canvas as well that should help you. So I'm only talking about part 2, which is looking at a word problem. And you're solving the word problem with systems of equations. So you're writing 2 equations, and then you're solving those equations with graphing, with elimination, with substitution, and then you're answering the question in like a full sentence. So there's a sample project that you can look at, but I wanted to walk you through just kind of the math of it. So we're going to do this problem, which is not one of the problems on the project, but just a problem that I found. So a movie theater charges $5 for an adult's ticket and $2 for a child's ticket. One Saturday, the theater sold 785 tickets for $3,280. How much of each type of ticket were sold? Okay, so first thing we need to do, define our variables. So what are we looking for? What is the question asking, right? So they're asking how many of each type of tickets were sold. So that means there were 2 types of tickets, adults tickets, child's tickets. So we're going to say X is the number of adult tickets sold, and then let's just say Y is the number of child's tickets. Yeah. Tickets, sorry, that apostrophe looks weird to me, I don't know why. Tickets sold. Okay, so those are the variables. So now we need to write our constraints, right? We need to write the equations that define how we are, what are the things we're thinking about? So there are 2 pieces of information that they give us. They're telling us, actually slightly more than 2, but they're going to be 2 equations. So the first thing they're telling us is one Saturday, the theater sold 785 tickets. So that number is important. So 785 tickets. It doesn't tell me how many of those are adults and how many of those are children's, just 785 altogether. So let's think about what that would look like as an equation. That means that the number of adult tickets sold plus the number of child's tickets sold. If you took all those tickets and you added them all together, they would be equal to 785 tickets altogether, right? Next, sorry, my neighbor is mowing their lawn. I hope that's not distracting. Next, they tell me that the total money I made that day was $3,280. Go movie theater, good job, get that money. So here, this is where it gets a little finicky. So if I think, okay, so how much money did I get from from adults tickets? Let's start with adults. So I know that each adult's ticket is $5. So if I sold, I don't know, 10 adult tickets, that would mean 10 times 5 is $50 from adult tickets. If I sold, let's say, I don't know, 50 adult tickets, 50 times 5 is 250. So that would be $250 from adult tickets. So I'm going to take the number of adult tickets right there. I'm going to multiply that times 5. So that's going to be 5 times X. Then I'm going to do the exact same thing, $2 for a child's ticket. Also, I don't know what kind of movie theater this is that is charging $5 for adults and $2 for children, but I want to go to there because, dang, that's cheap. Maybe they have like super old movies. I don't know. It doesn't matter. So I am going to do the exact same thing with child's tickets that are $2 and say $2 times Y. So 2 times every child's ticket. So if I sold 10 child's tickets, that would be 2 times 10, that's $20 from child's tickets, right? And I know when I add all that money together, all the money that I got from adult tickets, all the money that I got from child's tickets, that is going to be $3,280. That's how much they made. And on the project, y'all, I would really love for you to like label like, what do each of these mean? So this is like the money from adult tickets. And you can say this is the money from child's tickets. And then this is the total money right here. So if you like, go ahead and tell me what each part of your equation means, because that's going to help me grade you a little better, because I'm going to understand like what you actually know, right? I guess same thing up here. I could say like number of adult, oopsie, I can't spell, adult tickets. I'm going to say ticks. This is number of child ticks, and this is total tickets. Ticks. Okay, cool. So now we have our two equations. So now we need to find x and y. And remember, I want you to do this in three ways. I want you to graph them, I want you to use elimination, and I want you to use substitution. I think it actually goes graphing, substitution, elimination in the project. Make sure you read the project directions. Okay, so let's start with graphing. Let's start with the very, very first one. So in order to graph, I need to change these into something that I can graph. So that means, let me just write a little thing right here. So to graph, I need to either change to y equals mx plus b form. So that means that I'm just solving for y. I'm getting y by itself. I'm isolating y. So that's one way I can do it. Or I can also find x and y intercepts. So I'm going to, my chickens back there, that's where they live, in that little building right there. I don't know if you can hear them. Okay, so I'm going to do one of each of these, right? So for the first one, let's do actually the first one. Let's find the x and y intercepts on the first one. So I'm going to say, all right, x plus y equals 785. To find the x intercept, I'm going to set y equals to 0. So that means I'm going to go x plus 0 equals 785, which just means x equals 785. So the intercept on the x-axis would be 785, 0, right? The y-intercept, I'm going to set x equal to 0. So I'm going to say 0 plus y equals 785, which means y equals 785. So that intercept is going to be 0, 785. So that just means on your axes, actually, well, let's draw some axes down here. Let's use, I have graph paper, I might as well use it. And I'm only going to use quadrant 1 of the graph, so I'm not going to draw like x and y axes like that, like across like that. I'm just going to draw the L with just all positive numbers, because I'm not going to be selling negative tickets, right? So I need to get all the way up to 785 on both of these axes. I should label, let me label the graph before I do anything. So X is the adult tickets sold, Y is the child's tickets sold. So let me get down here and label it. So this is adult tickets, and this is child tickets. Okay, so I have my, let's make that an actual word instead of bad handwriting. Tickets. Okay, so I need to get up to 785. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I might just make each one of those 100, y'all. I think, yeah, I think that's going to be the easiest way to do it. So I'm going to adjust my scale a little bit. So this is going to be 100, 200, 300, 400, 500, 600, 700, 800, 900, and then I'm going to do the same thing on this axis. And your two axes don't necessarily have to have the same scale. It's usually easier to graph things if they do have the same scale, but they don't have to. 500, 600, 700, 800, 900. Let's go up to 1,000. All right. Okay, so that first one, this equation right there, I'm going to use blue for that guy. Let's do this. So I have an x-intercept at 785 and then a y-intercept at 785. So let me go down here and I'm just gonna have to estimate, y'all. So I'm gonna say maybe about there, it's about 785. And then let's go up here, same thing, I'm gonna estimate about 785. And then I can connect those, Shazam. Connect those like that. And that's my first line. I do want a color code, so I'm gonna go ahead and say, all right, I graphed that in blue. Okay, so let me scoot this over because I can do that. Scoot that over right there. Okay, so for the next one, let's change it to y equals mx plus b and graph it that way. So it's 5x plus 2y equals 3,280. So what we're going to do here is we're going to get the y by itself. So the first thing I need to do is move the 5x over there. So let's use green to do that. So minus 5x on both sides. Boop, boop. Those get to cancel out. So I've got 2y equals, careful, I cannot put these together. I can't do, oh, that just turns into like 3,275x. The 3,280 does not have an x on it, which means I can't just like, I can't put them together like that. So I'm actually just gonna write the negative 5x first, and then that's a positive 3,280 right next to it. So don't just put them right next to each other. Don't combine them together. And then the last thing I need to do is get rid of this 2, and that is 2 times y. So I'm going to divide both sides by 2. Boop, boop. So that leaves me with y equals, okay, so let's do this one at a time. Negative 5x divided by 2. I'm going to leave that as a fraction. So I'm going to say negative 5 divided by 2 with an x attached to it. And then 3,280 divided by 2. Shucky darn, y'all, I don't have a calculator. Let me go get a calculator. Well, I found a phone, but that'll work. Okay, so 3,280 divided by 2 is 1640. Okay, bad news. My y-intercept here is 1640, which is way higher than what I have on my graph. But that's fine, we can still use it. So this is my y-intercept, and then this, y'all, is gonna be the slope. So let's go. Oh man, how did we, I messed that up really, really bad. I should have done this before. Okay, so my y-intercept is 1640. So you know what, I'm gonna take the easy way out and just extend my graph up until we get to 1640. So this is gonna be 1100, this is gonna be 1200, 1300, 1400, 1500, oh my golly, 1600, and then 1640 will be between there. Holy cow, I apologize for that. All right, so let's start. 1640 is our y-intercept. So I'm gonna start it, I'm gonna estimate, it's gonna be right about there. And then my slope is negative 5 over 2. This means I'm going down 5 and then over 2. So I do want to end up going down, or I want to go downhill. I don't know which way I'm facing for y'all. I want to go downhill. So let's do this. I'm gonna just show you exactly what I'm doing. So I'm going down 1, 2, 3, 4, 5. Now careful, since I started like halfway between squares up here, I need to stay halfway between squares down there. And then from there, I'm going over 2. So 1, 2. So I should have a point right there. Okay. Now let's do that again. I'm going to go down 5. So 1, 2, 3, 4, 5, and then over 2. So that's going to be right there. And then let's do it one more time. I think I have room for one more. 1, 2, 3, 4, 5, and then over 2. So right there. Okay, so then let's go ahead and connect these in a nice straight line. Shablam, boop. Cool. Okay, so here's my graph. Oh, beautiful. Like, oh, dang, that's great. In fact, let me get up here and do a little highlighting so I know, hey, this one was in purple, the other one was in blue. And my solution, y'all, is right here let me use red. My solution is right here where they cross. The problem with graphing is that if the solution doesn't fall exactly on a line, I can't tell exactly what it is. So what I'm going to do is do the other two, and I'm going to come back and check it with this and see if it looks like we're in the right spot. So next I'm going to do substitution. And substitution, remember, is when you take one equation, get a variable by itself, and then plug that in from sorry, I just got an email. So here's the good news. We already solved this equation for y. So we have y by itself right there. So what I'm actually going to do, I'm going to go down here. I'm going to rewrite these equations again. So I have x plus y equals 785, and then y equals, 785, and then 5x plus 2y, 5x plus 2y equals 3,280. So in retrospect, we could use this one, but since it's got a fraction in there, y'all, I know that some of y'all, I won't name any names, but some of y'all really, really, really don't like fractions. So I'm going to try to use the other equation so we don't have to use a fraction. So what I'm going to do is I'm going to get y by itself. And technically I could get x by itself. It doesn't matter. I just need to get one of them by itself. So x plus y equals 785. To get the y by itself, all I need to do is subtract the x on both sides. So I have y equals negative x plus 785. Okay, so now that I know that y equals, I don't know why I wrote that so far away. I know that y equals negative x plus 785, then what I'm going to do is I'm going to take this little bit right here, and I'm going to plug it in for that y right there. Okay? So that's substitution. Substitution. So let's do it. 5x plus 2, and instead of y, I'm going to write negative x plus 785 equals 3,280. So I took, let me say that again. I took this whole thing and I just dropped it in for the y. So instead of 2y, I have 2 times all of that. Now we just need to solve it. So let's do it to it. I'm going to distribute that 2 to both those things. So I have 5x. What's 2 times negative x? If you're saying negative 2x, you are correct. Plus 785 equals 3,280. Y'all, I see a couple of really, really excited like terms here, and they're friends and they want to hang out together. They're not social distancing. Let's let them be together. What's 5x take away 2x? So I have 5 little x's. I take away 2 of those little x's. I have 3 x's hanging out. So 3x plus 785 equals 3,280. Then I need to get the x by itself. So let's subtract 785 minus 785. I have 3x equals, I need a calculator again. So 3,280, take away 785 is 2495. And then the last step there is to divide that by 3. Boop, boop. So x equals 2495 divided by 3. I get that, which makes me a little sad, but that's what I get. 831.666666667. 831.6 repeating. Okay, let me make sure I did all that right, because I thought I was going to get a whole number, but I did not. Hang on a second. Y'all, I messed up. I'm sure you're just like, Miss Ray, for like the last 6 steps. I totally messed up. I'm so glad you have seen. Look, I make a lot of mistakes. Here it is. It's happening in real time. So shucky darn. Let's go fix that. Here's what happened. Back up here, I drew these 2 little things, and I was like 2 times negative x, and I did not, do you see what happens? I did not multiply 785 by 2. Ooh, bad news bears, Miss Ray. Bad news bears. So let's get in there and actually multiply 785 by 2. I bet that makes things a lot better. Calculator. Calculator. There we go. No, calculator. Oh dear, this is just like real class, right? Goodness gracious, 785 times 2 is 1570. 1570. So I'm going to be subtracting 1570 here instead of 785. So minus 1570 minus 1570. So 3,280 minus 1570 is 1710. So 1,710. Divide that by 3, divided by 3. Oh my gosh, way better, 570 tickets. Whew, I was gonna say, dadgum, what did I do? We got that figured out. Not 3, Lindsay Ray. 570 tickets. So remember, X was adult tickets, so that's 570 adult tickets. So now this is where it gets super, 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 super easy, because what I can do to find Y, just plug in X. So I can use any of the equations that I want. I like this one a lot because it's super, super, super simple. So I'm going to say X plus Y equals 785. To find out what that Y is, I know that X is 570 plus Y equals 785. So then I'm going to subtract 570 from both sides. Boop, boop. And I get that Y is equal to 785 minus 570 equal to 215. So that means if I want to answer this in a sentence, which you do, you're going to say there were 570 adult tickets, 215 kids tickets. Okay, that was substitution. Very, very quickly, I'm going to just walk you through elimination. I'm going to walk you through the first part. So I'm going to write these equations again. So X plus Y equals 785. 5X plus 2Y equals 3,280. So elimination, remember, means that you are trying to eliminate one of the variables. So if I added these together or subtracted them, nothing would eliminate, right? So I need to do a little bit of finagling to make one of them eliminate. So what I'm going to do, I'm actually going to multiply this top equation by 2. The reason I'm doing that is because I have a 2y down here. If I could turn this into a 2y, then I can subtract those and the y's will cancel out, right? So here's what I'm going to do. I'm going to take this, I'm going to go 2 times x. I'm going to write these brand new down here. So 2x, and then 2 times y is 2y. And then don't forget that 785, Lindsay Ray. 2 times 785. 2 times 785 was 1570. Okay, so this is my new equation. And this equation is just as good as that top equation. It's just written in a different form, right? So now to eliminate these y's, I'm going to subtract that. And remember, I want to subtract everything, not just the y's. So let's do this real quick. Let's go blue. 5x minus 2x. So 5 x's, take away 2 x's, that's going to leave us with 3 x's. 2y minus 2y, nothing, those cancel out. Those are eliminated, that's what I want. And then 3,280 minus 1,570. That sounds really familiar, like we might have just done that. 3,280, yep. That is equal to 1710. So what I've got is 3x equals 1710. I'm going to divide both sides by 3. And x is equal to 570. Same answer that we got above, right? Yeah. Okay, and then you, for elimination, make sure you take that 570, plug it back into one of those equations and make sure that your y is the same. The last thing I want to do, guys, 570, 215. Does that kind of look like, I just want to double check here, 570 for x, 570, comma, 215. Does that kind of look like that place, 570, yeah, 215, not bad. I feel like that was pretty close, pretty accurate. So that's it. Those are the 3 ways to do it. Make sure you read the rubric to your project, because I definitely want you to be really neat with all the stuff. Show me all your work. And at the end, you do need to show me, write a sentence out about your answer. Y'all, if you have any other questions about any of this stuff, send me an email and I will try to get back to you ASAP. Okay, you are good at math. I will talk to you soon. Deuces.